Hello all, in today's video we are going to learn about the lab experiment on subnetting. I told you about subnetting when we were learning about the network layer. Subnetting is dividing a bigger network into smaller networks. Dividing a bigger network into smaller networks. The two main reasons for subnetting are to maintain security and ease of maintenance. For example, if you consider a class A address, the number of hosts or devices in a class A address are 2 power 24, which is a very huge number. If a network administrator had to manage these many devices in a single network, it would be difficult. But if the network is being divided into sub-networks or subnets, it's easy for the network admin to maintain and ensure the security. Let us take up an example for subnetting. Before telling you about subnetting, let me remind you of the fact that IP address consists of two parts, the network ID and the host ID. The network ID and the host ID. And let me remind you of the subnet masks or the prefix, which could be /8, /16, /24, /28, for example. Where /8 here, it means that 8 bits are used for the network address or the network ID and the remaining 24 bits are used for host ID. If it is /24, for example, the first 24 bits, that is the 3 bytes, are used for network ID and the last byte, 1 byte, 8 bits are used for host ID. From a total of 32 bits, we will choose a prefix, whether it is 8, 16, 24, it could be any number like 12 also. Okay. So that many bits will be used for network ID and remaining will be used for host ID. So now let us take up an example that I have a class C address where I have the prefix is /24. That means I will make use of 24 bits for specifying the network ID. So all this part specifies the network ID and the remaining 1 byte, that is 8 bits, are used for specifying the host ID. If there are 8 bits given for the host ID, I can have as many as 2 power 8, that is 256 hosts in the network. Now, if you are being asked to divide this network into subnets, for example, if you are being asked to divide it into 2 subnets, then 256 by 2 means each network will have 128 hosts. Okay, so now let us learn what will be, because the network, there are two networks now, I should have two network ID. I should have a network ID for subnet 1 and a network ID for subnet 2. I should have a broadcast ID for subnet 1, broadcast ID for subnet 2. I should also know what are the valid address ranges in subnet 1 and valid address ranges in subnet 2. So to learn that, you see, I will explicitly show the 8 bits which are used for the host part here and here, 193.1.2. Here I am making use of 0 to specify that this is one subnet, and I am using a bit 1 to specify that it is the second network. Okay, so this is the first subnet and this is the second subnet. So now the range will go from 193.1.2.000 to 193.1.2. This 0 will remain like that only, and all these zeros will count down to 111. And this, when I convert it into decimal, I'll get a subnet, I'll get a range from 193.1.2.0 to 193.1.2.127. Okay, the decimal value of this is 127 and the decimal value of this is 0. So in the subnet 1, I will have addresses ranging from 193.1.2.0 to 193.1.2.127. But the question is, if I want to identify this network, what will be the subnet ID of this network? So what I do is, I will reserve the first address, that is 193.1.2.0 as the subnet ID for the subnet 1, and the last address, which is 193.1.2.127 as the broadcast ID for the subnet 1. Okay. So how many addresses I have taken from 128? I have taken away 2 addresses from 128. So I will have a total of 126 valid host addresses ranging from 193.1.2.1 to 193.1.2.126 in subnet 1. Likewise for subnet 2. In subnet 2, we have reserved this bit as 1, telling that this is the second subnetwork. This value will come up to 193.1.2. In decimal, it is 128. Counting down till 193.1.2. all ones, that will come up to 193.1.2.255. Okay, this first address will be used to identify the second subnet. That is, this is the subnet ID for the second network, and this is the broadcast ID for the second network. Again, from 128 addresses, I have taken away 2 addresses, so I am left with 126 valid host addresses ranging from 193.1.2.129 to 193.1.2.254. 128 is already taken. What is left? 129. From 129 till 255 is taken for broadcast ID. So I will get it till 254. So this is about subnetting, where I am taking a network address, where I am taking an IP address and dividing it into 2 parts. If you would like to divide it into 4 parts, you will get 256 by 4, which is equals to 64 hosts in 64 hosts in each network. So it will be like this: 64, 64, 64, and each one of them will have its network ID, network ID, network ID, network ID. Each one of them will have its broadcast ID, broadcast ID, broadcast ID, and broadcast ID, and the valid addresses in each subnet. Okay. So this is what I have been telling you, that the range, subnet range in first network was from 2.0 to 2.127. The first address is taken as subnet ID. The last address is taken as broadcast ID. So we are left with 126 addresses. Okay. And then what is the subnet mask? Yes, what is the subnet mask for subnet 1? Because the first 3 bytes are used for network ID, all of them are set to 255.255.255, and we have 128 hosts in each subnet which we are making now. So it will be .128. Likewise for subnet 2, it will range from 2.128 to 2.55. This address is taken as the subnet ID. This is taken as the broadcast ID. Out of 128, we have taken 2 addresses, so we are left with 126. And what is the subnet mask for second subnet? It is 255.255.255.128, because we have 128 hosts in subnetwork 2. Now we have to write a program to implement the concept of subnetting. So what we very firstly require is, we require the important functions which you have to write is, you have to write a function for converting the IP address into an integer, and again an integer into an IP address. We have to do subnet mask calculation. How do I calculate the subnet mask? I should know the prefix length. So as input, I should take the IP address from the user and the prefix length. From this, I will calculate the new prefix length, and I will iterate through each subnet and will calculate the subnet ID. I will calculate the network address, that is subnet ID, the broadcast address, and the valid host addresses. Let us take, after writing a code for this, you have, I will show you the execution where I am entering the input address, IP address, for example, the same one which I have shown you in the example just now. Just to know that whether we have done it correctly or not. 193.1.2.0, same address I gave as input, and I gave the same prefix, that is /24 as my prefix. You see, What was the output? The number of subnets created were 2 and the number of hosts per subnet were 126. I told you that we have already taken out of 128, we have taken 2, so we'll be left with 126. Now I've just got the same screenshot of the explanation or the calculation I have just done near the execution of the program, where what is the network address of the first subnet network ID? Just compare. It is 193.1.2.0. Yes, we are correct. The broadcast address was 193.1.2.127. Correct. The subnet mask is 255.255.255.128. Correct. The range of addresses will be obviously from 2.1 to 2.126. Likewise, for subnet 2, the subnet ID will be 193.1.2.128. You can compare. Correct. The broadcast address is 193.1.2.255. You are correct. Then the subnet mask is same again here. And the valid addresses will be from after 128, that is 129 till 254, that is before 255, 254. So these are your first valid host addresses ranging from first address till the last address, for a total of 126 in each subnet when we are dividing it into two parts. So this was about your experiment on subnetting. Try to write the code for this and execute and check the output for the addresses which I have mentioned in the video. Thank you.